Alright, so here is the section 4.8. So we have discussed about a lot of things about the trigonometric functions starting from 4.1 to 4.7. At the end we looked at we discussed about the inverse trigonometric functions, but in this section we'll talk about the applications of those trigonometric functions. So we'll look at a couple of real life examples and we'll see how we can apply the trigonometric functions, trigonometric identities to this problem and then to solve it. Now, so basically they are ratios of two sides
of right triangles, and doesn't matter how the right triangles look like, any right triangles you will have the similar ratios based on the theta you have. And as we know that also from the also based on the theta, we know that one side will be there will be for sure a hypotenuse, and one side will be the opposite side and another side will be the adjacent side based on the theta. Now let's look at the real line problem, and we'll go back to those trigonometric functions for sure once we model the problem using those trigonometric functions. Look at this problem here. Find the height of the tower given, that is 150 feet from the line of sight of the individual who is looking up at the top of the tower at a 60-degree angle. Now here, one of the important thing I would point out is that it's really important to understand the problem and to draw the picture, because probably you will not have that picture in your question. So it's really important to understand the question and then to draw it. Once you draw it, I think the rest is simple, because you'll just apply the trigonometric functions. Now you see here, somebody is here and he is looking at the top of the tower, and angle of his sight is 60 degree. So you can compare this just like, and he is 150 degree far from the tower. So you can now compare this as just with a right triangle, because this is a right angle here, which is created at the bottom of the tower. That's the right angle. So here the line of sight, which is the blue line, is your hypotenuse, right? So, and as you know that we just always have one theta. We just take one angle as a theta. So now at this point you just know one angle, except the right angle. You just know one angle which is 60 degree. So based on that angle, first of all, what is your opposite side here? A. So which is the height of the tower, and exactly that is what we are looking for, right? So we are trying to find A here, which is the height of the tower, and based on the theta, because the theta is 60 degree, so the height is going to be your opposite side. And you are also given the adjacent side, because you see the adjacent side is 150. So now, first of all, we have 6 trigonometric functions. You can apply any of those, but some of those will be more suitable for the problem based on the ratios you have. Now, which trigonometric functions you think will be the best suited for this problem out of 6? Yeah, the tangent and cotangent both work best for this, because they both are defined in terms of opposite and adjacent. Okay, both of those, tangent and cotangent. If you remember that both of those are defined by those, and that's why you can try with other ones, but that will be difficult for this problem. And then nobody is saying that it will impossible. That's also possible, but it will be difficult for you to find those ratios using those, because when you have one equation and more than one unknown you will not be able to find it just from one or two or multiple steps. You might have to have something else, or you have to use Pythagorean theorem, which will be complicated. So now let's see. So the tangent, let's say we take tangent of theta. So at this point here, theta is 60 degree for us. So we'll take tan 60 degree, and tangent is defined by opposite by adjacent. So here the opposite is A,
and the adjacent is 50 feet, right? So let's write 150, later we'll write unit. So the 1060 is, how much is 1060? Is 1060 is square root of 3. You can use your calculator, it's up to you. Now, at this point, you have one equation and you have just one variable, so which is too simple to solve. So to solve it, what you want to do is you just want to multiply both sides by 150, because you want to isolate A, because that's why you are doing the solving the equation. So if you multiply both sides by 150, so it will be 150 square root 3 equals to A. So you are looking for A, so which will be 150 square root 3. Now you can do the math. To model the problem, just from the
plain word problem, just from it, the rest is simple, because all you need to do is just find the trigonometric functions, which is, or maybe Pythagorean in some cases, which is best suitable for that problem. And then, and you always will be your best bet will be, you at max have one unknown, because you cannot solve an equation if you have more than one unknown in one equation. Okay, in those cases you will need multiple equations to solve it. So so we don't have it here. Any question? Remember, the cotangent also work for this. So if you just work with cotangent, that will still work with this. I'm just trying to just make sure that we understand that cotangent also work. For an example, let me show you that how the cotangent also works, because so you understand that it's not only about one function, it may be multiple trigonometric functions that works. So the cotangent is your adjacent over opposite. So now, and the cotangent here, cotangent is 1 over square root, cotangent 60, cot 60 is 1 over square root 3, and here the adjacent is 150, opposite is A. Now you solve it and still you have 150 square root 3. So, you know, because that is still a relation between the opposite and adjacent. So maybe you have to multiply both sides by A, and then you have to divide both sides by, you have to multiply it by square root 3 again, and then you'll be able to solve it. But again, that's the same thing. So you have two options. In the next problem, the length of a kite string. Somebody is flying the kite, so its kite string is 30 feet, and when the kite is 10 feet above the ground. Now here the kite string is the blue line, which is technically the hypotenuse of your right angle, and the height of the kite is 10 feet. So what is the distance between the person flying the kite and the point immediately below the kite? Now the point where he is flying is capital A here, and the point immediately below the kite is point C, capital C here. So we are looking for the distance between A, capital A, and capital C, which is small b. I'm saying this is the way we have written that. We have just drawn the graph or picture or images. You probably have your own variables or names, doesn't matter. Now, for this problem again, we'll be applying some trigonometric concept. So what do you think? Which one will be the best suitable option you have? If you look at here carefully, first of all, you probably will notice that you don't have any angle here. At this point, you don't know any angle. Okay, you can find an angle because you have two ratios, and you can do something else based on the angle. That's one option. But probably the easiest would be you can use the Pythagorean, because remember, according to Pythagorean theorem, which again it can be only applied to right triangle, the square of the hypotenuse equal to the square of the
opposite plus square of the adjacent, right? So which is, in this case, if you try to apply the Pythagorean, because you already know two sides and you are looking for the third one. So so basically this is what you will have. 30 square must be equal to 10 square plus b square, because the 30 is your hypotenuse is 30. So the hypotenuse square equals to the opposite or whatever is, because we don't know exactly which one is opposite and which one is adjacent at this point, because we are not considering anything as theta. So just take other two sides, 10 square and b square. Now it's quite simple now to solve b. So the b is going to be b square is going to be 30 square minus 10 square, and then 300 minus 100, and then b is going to be square root of 200 feet. Now in general, when you do the square root, we always take the plus minus, but in such cases we don't take the negative ones, because these are distances, and unless you are saying something in physics, in general we assume that the distances are positive. So we just, we'll only take the positive value of the square root. 900, I'm sorry. It's 900 minus square root of 800, and how much you get from square root of 800?
It's probably 20 square root 2, right? Let's see,
2 times 10, yeah. And then you can solve it again, because it's probably it's 1.44 times 20, which will be 28 point something, 28.8, 28.28, are you sure? Something like this. Yeah, because probably the factor, the square root of 2 is 1.414. That's why. So, all right. So, so we applied the Pythagorean theorem, and so during the test you will have access to all the formulas. If you want, I can give you all the formulas of all the trigonometric functions, so you don't need to remember anything or memorize anything, but we have to understand which one to apply. That's the important part. So whenever you have all the formulas, in real life you have all the formulas open, so all you need to do is you have to understand which formula to use. Now let's look at, I picked a couple of problems from the book, and these problems are, there are several other problems, but these are like covering the variants of all the problems. So here a hot air balloon is ascending with you in the balloon as a friend's filming your ride. Okay. Now someone is in the balloon and someone is filming. Now let's say the person who is filming, he is here at the ground, and the other person is at the balloon. Now when your friend first starts filming your ride, her camera is at 30 degree at angle. So when the filming started, you were here. Okay, and then after a minute her camera is at 70 degree angle, because after a minute you went to the top, and then look at this. At the beginning you were looking at your friend, the person who was filming, he was or she was looking at here because you were here, and the angle created was 30 degree, and then now you are at the top, so the angle created is 70 degree. Now the question is, how far did you travel in that minute, and in that minute? So that's an interesting question. So how far you travel in that minute? Now using the trigonometric functions, you'll be able to find, because since this is a right triangle, So you have two right triangles. The first one is here. Because of that 30-degree angle, you can assume there is a right triangle, and you can find this height, right? You can find this height, and using the 70-degree angle, if we assume there is another right triangle, which is the bigger one, you can find B, which is another height. Now the question is asking how far you travel from the point when the filming started and up to now. So it's basically B minus A, which the question is looking for, because they are looking for what is B minus A, which means what is the distance from here to the top. So to get the B minus A, you will need B and A both. Once you have B and A, you are done. Now, getting A is also simple. So you have to consider two different triangles here, right triangles. Now the first case, you will take the small one, small right triangle, where 30-degree angle is known, which is your theta. You will know the adjacent side, because since this is the theta, so this is going to be the adjacent side, which is 50-degree, and you will be able to find small a, which will be the opposite side. And using the bigger right triangle, you will be able to find the small b. Once you know the small a and a small b, you will be able to find b minus a, which is exactly the question is looking for. Okay, so this is the point where filming started, and then you traveled for 1 minute, and after 1 minute you are at that high. So the question is, how far did you travel in that minute? And the answer is b minus a. Now let's see whether we can find b and a both. Now first of all, to find the a from the small right triangle, what will be the best trigonometric functions? Look at the small right triangle. You know an angle. So based on that angle, you
know the adjacent side, and you are looking for the cotangent. So tangent 30 for the small triangle. Tangent 30 is going to be opposite over adjacent. Now here the opposite is small a, right? That is your opposite, the small a. And the adjacent is 50 feet. Now the tan 30 is 1 over square root 3. You can do it in the calculator as well. So now if you try to solve it, it's going to be small a will be 50 over square root 3. How much is that? 50 over square root 3. Anyone has the answer in fraction? What is the answer in fraction? Get this answer in fraction. Let's try other triangle to get the b, small b. So this time the angle is 70 degree. So the adjacent side, so is again opposite by adjacent. Now here the opposite is small b, adjacent is still 50 feet. So 1070. How much is 1070? Let's keep it 1070, so you can plug in the calculator as 1070. So the small b is going to be 50 times tangent 70. How much you get for a small b? How much? 137.37 feet. And how about that?
small a, 50 divided by square root 3. Now you have small b and small e, a small a. So when you subtract b minus a, you will get the height. Not the height, is basically get the distance you traveled in that minute. Now what is the speed per minute? Again, the same thing, because the speed per minute is basically the same thing, because how far you travel per minute, that is basically your speed. So that will be the same answer. So that is your speed per minute, because in 1 minute you travel b minus a, and that is going to be your speed. How much? 108.50 feet, which is b minus a, and that's going to be the speed as well, because if you divide it by 1 minute, because you traveled it for 1 minute, you travel the distance for 1 minute. So any question here? So I think the most important part here is to draw the picture and to understand how you can apply the trigonometric functions here, because once you apply it, the rest is simple, evaluation or calculation, solving equation. Let's look at something called trigonometric bearings. So here, for an example, if you look at these ones, these are our all the north, east, west, south you are looking at. But sometimes when people travel, they let's say you are traveling or sailing in the sea, and then they define or they talk in this way, that let's say you say you have, they call it bearing from O to P. Now here O is the origin and P is the point where you are at this point. So from bearing, for the bearing from O to P means you will start from north and you created here a 40 degree. So it is called as north 40 degree east, because you are going from north to east to create the angle. Look at this, this is your east and this is your north. So create that angle, you are going north and you are going towards east to create that angle, but you went like 40 degree east. So basically you are starting from north and you went 40 degree towards east to create that angle, and that is called a bearing from O to P. Similarly, look at the other examples here. Let's say here, this is north 65 degree west, because you started from north and then you created 65 degree angle towards the east side. Okay. So the last one, south 70 degree east. So you started from south and went towards east side 70 degree. Okay. So once we know it, we'll try to solve a problem using this kind of bearing information. But before that, let's see whether we understand those. Now, see, in all of this problem, the O is your origin. Now, can you find that what is the bearing from O to B? Your B is here. Look at the B, which is creating 30 degree with north. Look at the C, which is creating 70 degree with the west side. And the last one is D, which is creating 20 degree with the south side. Now let's see whether we can just define it, or we can define it in terms of bearing. Try. All right. So what is the first bearing from O to B?
North 30 degree west.
Yes, north 30 degree west. Right. How about the O to C? Yeah, so you started from west. So let's see whether we can write it here. All right, so the first one, bearing from O to B. O to B is north 30 degree west, and O to C is west 70 degree south, and O to D south 20 degree east. Any question here? Here, O to C. Because look at the angle created. Okay, so you started from west and you are creating this angle to go to C. So you are starting from west and you are going towards south. So that's why it's west 70 degrees south. Any other question? If not, let's look at a application problem with this. Now here we have a problem with the bearing information. Harbor and travels 30 miles on a bearing of north 40 degree east.
So this is your north, and it started from here. So it's north 30 degree east should be this line. Okay, and then the captain turns the boat 90 degree clockwise and travels 20 miles on a bearing of south 50 degree east. So at first you started from here and you just the captain traveled north 40 degree east up to here, and now the captain turns the boat 90 degree from this point. So basically a 90 degree angle is created here. Okay, it turns from here 90 degree from here and travels 20 miles towards south 50 degree east. Now here look at this north south line. So south 50 degree east means, so you start from south and go to east, go towards east. So this is going to be the line and you traveled up to here. Now the question is, at that time how far is the boat from the harbor entrance? Now this is your harbor entrance and you are basically small c far from the distance. Now remember, this question, if you try to solve it, it will be extremely simple and easy because you can just apply the Pythagorean theorem to solve it. But the important part here is to understand the question, because if you understand the question and if you understand how to draw it based on the bearing information, then the rest is simple. Because if you look at this triangle, this is a right triangle here, 90 degree created at here, and small c is your hypotenuse, and you are trying to find the small c while other two sides are given. So the best approach would be Pythagorean theorem, where you just know that the square of the hypotenuse is equal to the square of other two sides added, which we already know in here. The other two sides are 30 miles and 20 miles. So if you are trying to find the c, if you are looking for the c is going to be square root of 30 square plus 20 square, which is going to be 900 plus 400 square root, so square root of 1300. How much?
36.06 feet or miles, I'm sorry, just miles. So that is going to be your distance from the harbor entrance to the boat. Any question for the first part? There is one part here. What is the bearing of the boat from the harbor entrance? So basically, what is the bearing of the boat from the harbor entrance? Now to find that, now this is the harbor entrance, and to find the bearing, you have to know this angle. You know the part of the angle which is 40 degree. To know the complete angle, you have to also find the theta. Now, how do you know that's 50 degree? This is not a right angle. No, this is not a right angle. This is not a right angle, so you don't know that is 50. So you have trigonometric functions for that. Maybe this is the time you need to apply some inverse function. Now to do that, let's do it in this way. Let's try to see whether we can apply some trigonometric functions to know here what's going on here. So to know the angle, you want to know the theta for sure, right? Because once you know the theta, you will know this whole angle, which will be 40 degree plus theta. Okay, you will know this whole angle, which will be your 40 degree plus this whole angle. Then you will know the bearing of the boat from the harbor entrance, because the boat is here right now. So to know the theta, what you can do? You can apply now at this point. If you look at carefully, if you look at the question, you know almost all the sides, right? I'm saying you know the hypotenuse, you know the other two. So let's say I write tan theta here.
So look at this question carefully. If I assume this is the theta, what is your opposite side? 20 miles, right? That is your opposite, and 30 miles is going to be your adjacent side. Now, so the tan theta is
Opposite by adjacent again. So that means 20 over 30. Now remember, you are not looking for tan theta, you are looking for only theta, right? So let's make it simple. So it's 2 over 3. Now what you need to do is you want theta in the left side. To do that, you can take tan inverse in both sides. Because remember those identities. If you just do tan inverse of tan of theta, it becomes theta only. So this will be, I'm taking tan inverse to both sides. This is what I have right now. If you take it in the left side, you will be left with only theta. In the right side, it will be tan inverse of, I think you can solve it simply, right? Just using the calculator. Now you will know the theta. So theta is going to be, theta equals to tan inverse 2 over 3, given the information. Remember, tan theta was not the only option. We could have used any trigonometric functions here, because any of the 6 trigonometric functions, because you know all the 3 sides. Since you know all the 3 sides, you can apply any of those. You can apply cotangent, you can apply sine, cosine, cosec, sec, any of those. I just choose tan theta, but you can choose any of those. And at the end, you will have the same answer. Doesn't matter which trigonometric function you use. How much you get for the theta? What is the degree? Remember, the calculator will give you the degree in radian. How much you got? How much you get? 33 point. That is in degree. That is in degree. Or probably your mood is in degree. Okay, whatever. If it is in degree, now we can answer that question. So all you need to do is you have to add the theta with the 40 degree. So it will be 33.69 plus 40, which will be 73.69. So if we have to define the bearing of the boat from the harbor, how you define it? So you start from the north and then 73.69 degree east, right? Because this is the east side. And you started from here, you are going to the east side, and you went 73 degrees 69, 73.69 degree. So north 73.69 degree east. That should be the bearing of the boat from the harbor entrance. Any question here? All we did is we just added the theta and 40 degree, because once we have the theta, we can add with the 40 degree, and we started from north, and then we are going to the east, and we went like we covered 73.69 degree. Any question here? All right, so let's look at simple harmonic motion. Now, this simple harmonic motion is a popular topic in physics. Okay, so in this class, we will not be going too far. We'll just try to understand what it is, just a basic thing, and also we'll try some application question. The reason we have this one at the first, because simple harmonic motion is a periodic motion, okay, and all the trigonometric functions are periodic functions. So that's why those kind of motions can be easily defined using the trigonometric functions. Now, to understand that, let's say we have a now, for an example, let's say if you just
in the middle level, okay, when the ball is resting, it is not moving. The ball is staying here at the D level, D goes to 0 level. Now what happens, let's say if you pull it up to D goes to -4 level, and then you just when you pull it and then unhold it, it starts moving, right? And then if you look at this carefully, what happens is at the time 0, let's say when you started, it was here, okay? At the next second, maybe, it is here. At the next second, it is here. At the next second, it is here. And look at the motion here. The way it will be moving is like this, right? And if you think about that movement with the time, look at the red curve. That is exactly like the sinusoidal curve, right? That's how the periodic motion basically is related to the periodic functions, because that movement is nothing but it creates a sine or cosine. Because we know that red curve, right? That is extremely similar to the sine and cosine curve. And this is called the harmonic motion. So anything which has this kind of periodic motion, so we call it harmonic motion. So in physics, the distance it is moving, because the distance it is moving is a little bit interesting, because at the beginning it was at 0, and the peak level is 4 and -4, because for any, even if you can compare it with any sine or cosine function, because in sine and cosine we have amplitude, which is the maximum peak or the minimum peak. For this case, the maximum peak is probably 4 and the minimum peak is -4, right? So pretty much it's a similar thing. So, and look at the formula we have for the distance here. We define it either by sine or cosine. We'll talk about that a little bit later, that why it is when it will be sine or when it will be cosine. Now the A is your amplitude here,
So as you can see here, the A will be either 4 or negative 4 based on the situation. We'll talk about that. And the omega t can be compared to bx. Remember that bx in our some of the equation, generic version bx, and then we use the b to calculate the period. Remember we used the b for let's say 2 pi by b was the period for case. Similarly, 2 pi by omega is the period here. That's exactly the same thing. Remember the 2 pi by b was our period in the generic equation of the sine, and 2 pi by omega here is our period. Okay, so where the omega is always greater than 0. So we know the amplitude here, we know those, and let's see whether we can solve some application question for this kind of harmonic motion. Anything which has a harmonic motion can be solved using the trigonometric functions. Now here, one of the things which is little bit important to understand, which is not written in the slide, when it will be sine and when it will be cos, because we know that the sine and cosine both has the same curve, except they have a phase difference of 90 degree. Okay, because when the t is 0, the sine is also 0, or when it's like when the pi is 0, so not pi, the theta is 0, the sine is 0, but at the time that cosine is 90, cosine is 1. So when it will be cosine or when it will be sine, that's an important point. Now for each and every problem, we look at when t equals to 0, what was the position of the object. Okay. For an example, in this case, when t equals to 0, the position was at the negative side. Okay. If the position is not at the rest level at t equals to 0, we'll always use the cosine. Whenever at t equals to 0, the position is at resting level, which is 0 level for us, we'll assume that we'll use the sine function. Let's say for this case, for this picture here, we'll be definitely using the cosine function, because whenever the t is 0, it is not resting. It is not in this level, 0 level. It is in peak level. I'm saying the negative peak, right? So that's why for this one we'll be using the cosine. So that's based on that, we'll be choosing cosine or sine. Now, and also, what will be the amplitude in all of the problem? Remember, the amplitude is again decided based on the initial position of initially where it went from the resting level. Now here, for this case, initially it went to the negative side. So the value of A here will be negative 4 because it is in negative side. Okay. In case of sine, what happens? The initial amplitude then. The amplitude will be when it starts moving, where it is going first. Whether it is going to the downside initially,
that means your amplitude is going to be negative. If it is going to the some information you must have to know, because otherwise your sine will be mismatched or cosine or sine will be mismatched. Now let's see how we can solve a real life problem here. A ball on a spring is similar to situation here. It is pulled down 5 inches below its level when it is at rest. Now, so it is already pulled down from the resting level, right? From its resting level. So it's pulled down. How much is pulled down? 5 inches. Now, a couple of things we know from this first line. One is pulled down 5 inches, so that is going to be your amplitude. And the amplitude is positive or negative. Remember, we said that we always consider the initial amplitude. Initially, it was pulled down, so that means it's negative. Because let's say this is your resting level, and that is your upper side, and that is your negative side. So when you pull down, you are going to the negative side. So automatically, your A is going to be negative 5. Because it's 5 inches, so the A is going to be 5. I'm sorry, the negative 5 for this question. So A is negative 5. Now the next question, what function we are going to use, sine or cosine? It must be cosine. Look at the initial position. It's not at the resting level. Initially, if it is at the resting level, we consider it is sine. If it is not at the resting level, it's at negative peak, so that means this is cosine. So we'll define that by cosine. Now,
What else we are given? The period of the motion is 3 seconds. Now what we can find from the period? Now remember here, in such questions, the period means 2 pi by omega, which is pretty much similar to 2 pi by b. Remember, we tried this 2 pi by b. Our generic equations was, let me remind it, because just to make sure that we understand that we are still working with the similar problem. Remember, our generic equation for sine x or cosine x was this. Remember this one? That was the generic equation. Now you can exactly compare with this, because all we are doing is this. Now here, the difference is this. The generic function was defined in terms of x, because that was a function of x. Now this is a function of t. So you know, it doesn't matter. It can be function of anything. And here b can be compared with the omega. Okay? So we don't have any horizontal or vertical shift here, because every time we are considering that we are on the x and y axis, and that's why you don't see capital C or capital D here. If you have any capital C or capital D or something like that, we'll know that there is some kind of vertical or horizontal shift, but there is no in general, because anytime you are moving something, you assume that that is your x-axis. So that's why we don't have any C and D, but you can pretty much compare with that. So that's why your 2 pi by omega, just like 2 pi by b, is your period here, which is given as 3 seconds in this question. Now, what we can do from this part? From this part, what we can do is we can find the value of omega, because this is going to be your equation. So your original equation is d equals to a cos omega t. Now here, this is a function of t. How do you know it? Remember the last slide, we just know that that's the distance, the function, that's the equation of the distance for any harmonic motion. Okay, anything which is moving using a harmonic motion, we will have the same equation, except it may be sine or cosine based on the initial position. Now here we already know the a, which is -5. We know that this is cosine because initially it was at the negative sign, it was pulled down, but we don't know omega. We know that t will be always here because it's a function of t, that's a parameter, but we have to know what is omega, and we can know it from here. If you solve this equation, the 2 pi by omega equals to 3, you will find that omega equals to 2 pi by 3. If you solve it, right? That's exactly what you will have. Now, rest is simple. You just plug those values here. So the question is asking you to write an equation for this harmonic motion. To do that, all you need to do is just plug the value. So you know the a, which is -5, and cos omega is 2 pi by 3 and then t. So this is going to be the equation for the harmonic motion. It's pretty much simple. Just the only thing we need to understand is how to find the a and how to find the sine function, whether the a will be negative or positive. Because in most of the question, what is your question?
Why is the t multiplied by 2 pi?
It's the same thing. That's exactly the same thing, because it doesn't matter whether you multiply with 2 pi and divide it by 3. If you do that, or if you just multiply the whole thing by t, that's the same thing. Take any value of t and try it. It will be exactly the same. Yeah, because here the 2 pi by 3 is a constant. So anyway, that is a constant. His question is why you do not write this. You can also write that 2 pi by 3, and you can write t here, but that will not make any difference. That will be the same thing. And the next part, what is the frequency? Now the frequency is a
extremely popular term in physics. We also have frequencies in mathematics. The frequency is a reciprocal of period. Now, what the period tells you, remember the period from the sine and cosine, the period was the time you need or the angle you need to complete the cycle, right? Now, if you take the reciprocal of this, that means you are saying that how many cycles someone can complete in 1 second or in one time unit. Okay? So which is extremely simple. When you know the period, just take the reciprocal of the period, you will get the frequency. So here the period is already given in the question, which is 3 seconds, right? So the frequency will be 1 over period. So 1 over 3 seconds. And the unit of frequency is hertz. People write it Hz. I'm sure that you have taken some physics classes, right? Or you are going to take. So you will see those in physics classes for sure. But the reason we want to talk about this kind of application questions here, because these are harmonic motions, and all the harmonic motions can be defined using using trigonometric functions because they are periodic. As you can see from that motion of that ball, you saw that after completing a cycle, the ball is at the same position after a while, right? It's coming to the same position again and again and again. Any question here? So in fact, the frequencies calculation is simple. You just do the reciprocal of period. So that's probably a little bit newer here. Let's see whether we can answer. So we are almost at the end of this section, and let's see whether we can answer some of these questions. So what is the bearing from O to A? See, the angle is given from east side, right? So you are going from east to north. So it's something like east 10 degree north, which is C. Which is C. But I'm just trying to make sure that we understand it. There are some just check it with your book, but because I forgot to check it with the book, because there are some conventions like this. In some places people always want to consider the angle clockwise in case of bearing calculation. They always want to consider the angle clockwise. Just check with the book that whether the book also want to do that. If that is the case, then you should start from angle from north side, and you have to consider this angle here, which is 80 degree, because the complete angle is 90 degree here. So in that case, you should have the answer north 80 degree east. So which would be B. Okay. So check the convention, because I know that there are some places where they follow that convention that all time the angle is going to be clockwise angles. Okay. Now, if the book suggests that, I forgot to do that. I was thinking that I'll probably check with the book, because I know that there are places where they just tell, okay, you have to always consider the clockwise angles. Okay. If you have to do that, your answer should be B, because in that case, this is 10 degrees, so you'll be considering the other degrees, which is 80, because in the total degree is 90, right? So let me draw it here, and then you'll understand what I'm talking about. So here, let's say this is your 10 degree, okay? But look at this. You are saying that I'm starting from east and I'm going towards north. So the angle is calculated anti-clockwise, right? Do you see that is anti-clockwise? Now, if the convention, you have to start from here, because it's all about this line, right? So to come to this line, you're going to start from north and go all the way
to here. So if it is clockwise convention, then this is going to be 80 degree, and you will say north 80 degree east. I'll probably double check tomorrow. I'll check with the book just to make sure that book doesn't have that kind of issue. If it has, then the right answer should be small b.
Okay, whatever the angle is given, we will always consider the angle with the clockwise directions. Okay. But I don't think so. But in general, I don't think so. But I just want to make sure. All right. So here, find the height of the tower to 2 decimal place. Now let's see what is given here. Height of the tower is small a here, and you are given an angle 50 degree, which is your theta, and you are also given a distance of 20 feet. Now, if you consider the 50 degree as your theta, what is going to be the opposite side? Small a. So, and that's exactly what you are looking for, and your adjacent side is going to be 200 feet. What will be the best trigonometric functions? Tangent or cotangent. So, and the rest is, I think, simple. Once you have the tangent 50, it will be small a over 200, right? Tangent, let me write it down here. Tangent 50, then you can solve it for sure. So the tangent 50 equals to height, which is opposite side here, over adjacent side. I think rest is simple, right? So your answer will be something like small a 200 tangent 50. 200 times tangent 50. What is the right answer? So everyone has A, 238.35 feet. So you will just do 200 times 1050, you will have your answer. Okay. So that's the end of section 4.8.